So good afternoon, everybody. Hope you enjoyed your lunch. The good news is this is not going to be a high code-heavy talk, so you won't fall asleep. The bad news is this is not going to be a high code-heavy talk, so you're not going to learn a lot of code out of this. The primary goal of this is for you to understand why you want to do certain things with core data. As opposed to me saying, this is the way you should write the code, copy it down quick, I would rather you understood the logic and the thinking behind it. And hopefully that way you can wade through all the Stack Overflow questions and answers out there and all the blog posts and say, okay, this answer makes sense, this answer doesn't, and you'll know the rules behind the spirit behind the rules, as it were, as we were talking at lunch today. I myself these days, in addition to help run the company, I do a lot of code reviews, and I do a lot of one-on-one tutoring with other developers, specifically in the area of core data. The bad news is I get to see a lot of bad code, but the good news also is I get to understand how people got there and how they got to the hole or the corner or the pitfall that they got into. So hopefully we can help get out of those, or at least avoid those in the future. I always say after my talks, if you learned one thing, not the whole talk, but just one item that I've changed your mind on, I win. So hopefully out of all this today, I'll get each and every one of you to have one thing. So topics of discussion today, there's 3 main points and 2 small ones. First small one is just going over the core concepts, things that I hold as absolutes, things that I consider to be the foundation upon all of which all the other logic comes out of. This is what my x's and my y's and my z's equal, so that you can figure out the formulas from there. Second one is I'm going to go over the old way to build and use core data. And old is a questionable word, but we're going to run with it for now. And then, for sake of completion, I'm going to show you the hard way. Don't do this. But I want you to know that it's out there, that it's possible, and that there is another option, and then I'm going to explain to you why you should never, ever, ever do it. And then we're going to wrap it up with showing you the best way. And we're going to start that off by defining what best means. And then we'll cool down with a bit of guidelines, general rules of thumb that I go by, advice that I give to everybody, and more importantly, why. So we'll actually start off with why. Why would you want to do multi-threading? It's a trick question. Most time when I ask this question, people will come back, well, my app is slow. And my answer is, failed. That's not the right answer. Multi-threading is not a silver bullet. I'm sure you've heard that on the internet many, many, many times. It's not a fix-all, nor is it something that you add later because some part of your application is slow. Multi-threading, when you're designing an application to be using multiple threads, you need to go into it with your eyes open, and you need to plan for it as you're developing the application. You can add it later, but that's just asking for pain. It's something that you need to think about as you're moving along, going, okay, at what points in time do I actually need to be doing more than one thing at the same time? And that is the right answer for multi-threading. It's not, I've got a block, this screen pauses, I'm getting a beach ball here if you're on OS 10. Those aren't the right answers for it. It's, right now while the user is doing X, I need to be doing Y. That's when we need to start thinking about multi-threading. And that's when we want to be designing it into our application. And the other answer, which is the why not, is the user's not doing anything, but they might soon, so I want to do this other stuff in the background. I want to sync with the server. I want to refresh some data they haven't looked at. Things like that. I want to draw this image just in case they need it. I'm going to do it in the background. So in case they decide to jump in, I want to be able to interrupt myself and let them have it. So that's the other answer of the why not, is if you design an application that has a lot of situations where the user's pausing, they're waiting for something, they're just looking at your screen, they're watching a movie, they're reading a Twitter stream, things like that. Hey, you've got free cycles. Can you use them without ruining the user's experience? And the core concepts, these are my foundation. This is my bedrock that I live off of whenever I'm either designing an application or helping to correct an existing application that's out there. And I preach these, and if you walk out of here thinking, I already knew that, you're ahead of the game. Trust me, you're ahead of the game. Hell, you're ahead of the game just being at the conference. A lot of developers don't take that step. So think of it that way. If you're already here, great. If you already knew these core concepts, pat yourself on the back, have your friend pat you on the back because you are winning. You are well above the 80%. The first and absolute rule, and DBAs tend to live by this one, this is where I got the rule from originally, is that when it comes to core data, there is a single source of truth. Specifically, there is one mock, one NS manage object context that you, the developer, decide is your truth. This is where all of your UI is going to come from. Your entire user interface is going to decide what to display based on that one manage object context. Not 2, not 3, not n, 1. If you don't do that, there is a pit waiting for you somewhere. Maybe not today or tomorrow, and might not even get you, it might get the next guy, but it's there, guaranteed. The UI thread, the main queue, whatever words make sense to you, that is the one that your truth lives on. Truth and UI, they go hand in hand, they're together. Your user interface, despite no matter how hard you try, is a single-threaded organism. That's true in Cocoa, that's true in Swift, that's true in Java. Pick your language. They are all, the user interface is designed to be on one thread. Anybody accidentally built up a view control on a background thread? You already know how that happens. It doesn't end well. Sometimes, which even drives you even crazier. Therefore, because your UI is on a single thread, you want that manage object context to be on that same thread so that they're talking to each other on the same thread. I always think of threads as silos in the universe. And they're in that same silo and they can talk to each other and they're not crossing silos. So those two go together. Again, foundational knowledge. This is my truth. Now this is the big one that a lot of people yell up and scream at. Never, ever, ever manipulate data on the main thread. The user can. That's okay. If they want to edit a field, that's perfectly fine. That's what they should be doing. That's what it's there for. You, the developer, the data processor, the person who's consuming data or pushing data somewhere, you don't get to touch that thread. That's not yours. Get off of it. Always, 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 always. And especially if you think, oh, it's just a little bit, especially then. Doubly so if there's a possibility of double of 100. Never, 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 never. I don't know how many times, and I've done it myself. These are not rules of me, I'm not bringing these down on stone tablets. I've done this so many times, and it finally woke up and go, wow, this is really bad. I got to stop doing this. I see this all the time. Apps come to me and they're like, we stutter here. We can't get this animation smooth, because usually it'll go to one of our other guys because they're trying to solve the animation problem. And then our animation expert will look at it and run it in instruments and go, you don't have an animation problem. Your animations are just fine. Go talk to Marcus. Wear a helmet. It's amazing how this little thing can just trip you up. You're like, oh, I'm just going to pull in this little bit of data. True story. By the way, I love telling stories. It's one of the great things I do. And they're always how I screwed up. Almost always. Well, this one actually I did screw up, but it's not part of the story. I was working on the Daily a few years ago. God, 2010, 5 years ago. And we had an ad company that we were working with who were going to be producing ads for the iPad. And we got their library. Thank you very much. By the way, I'm also against libraries. That was last year, though. And it was a binary library. We didn't even get source code. And we had rules. Documentation, put this here, put this there. This is how you initialize it, blah, 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 blah. Set it all up. Everything worked fine in tests. And we deploy out to our beta group. And they've got a different magazine data than we do. Because ours is really, we have a lot of magenta, and we have a lot of, very contrasting colors, and it's all test graph. Where they actually have a live data, something that looks like a real magazine, because they're users, and they need, they don't understand that contrasting colors is valuable. So they've got real data. And they come back to us going, the app crashes on launch every time. We run it through our stuff. It's fine. Nothing is wrong with this. So we switch over to their data. Sure enough, Crash on launch every single time. Look at the crash log. Oh, it's bad food. Bad food means watchdog killed you. Your launch is too slow. Go to profile their data, and sure enough, that initialization code from that advertiser was taking anywhere from 9 to 60 seconds, stopping the main thread. Okay, so we threw it on a background thread. That didn't work. It worked for us, and then they flew in the next day going, what did you do? Our databases are blowing up because apparently somehow we put a hole in the universe. And they made us put it back on the main thread. And we're like, okay, to be on the main thread, it's got to be below 8 seconds because we launched fairly quickly, and you're taking it all up. What are you doing? And they're like, oh, we're not doing much. And they refused to tell us, of course, by the whole IP crap. So we decompiled it, because that's what you do with other people's IP, right? What they had done, what the developer had done of this code, and it's really not the developer's fault, it's his fault. On launch, he's checking their assets that they have unzipped in their cache directory, because that way they can load them and display them quickly. However, he wasn't checking to see if they were the same assets that were in the zip file. He was just unzipping a zip file from disk into that caches directory every time to make sure that he always had the current assets. And then during some time later, he would launch a background thread and download new assets, which was fine. That part was fine. It was the unzipping which was causing the randomness, because we were running test data. That zip file was 50 kilobytes, it unzipped instantly. And his test data was 50 kilobytes and it unzipped instantly. The production data was 15, 16 megabytes. And it was like thousands of assets because, every single little circle has got to be slightly different with a slightly different shadow, and therefore we need 80 of them on the screen. And of course, their magazine, their advertisements looked beautiful, but they were just thousands of files on the disk, and therefore that was giving us our variation on the zip file, because the zip file, depending on which ads were coming down in this cache, we're taking this zip file to unload it. And the moral of that story is the developer is like, oh, well, these cache files are only 50 kilobytes. I'll just unzip them on the main thread. It won't hurt anything. And unbeknownst to him, the designers who had no idea that he had this expectation were like, we can just cache the whole ad. And that way it will come up now. And that way we won't get yelled at for our ads taking too long to load. Big surprise. So that was a very fun, and that caused an incredible amount of drama. Unbeknownst to that poor developer, we had people whose names are generally in the newspaper every week, in a conference room trying to figure out whether we were going to continue to run with this ad company or not. And there was literally millions upon millions of dollars on the table because of that single decision of how bad can it be. So those are my core. This is what I live by with core data, with any persistence engine at all. It's not just these are not core data specific, but they work very, very well. You follow these 3 rules alone, and most of the times you will not have problems with core data. That simple. So from there, we're going to go through what I consider to be the 3 correct ways to use core data to build a core data stack. These are design patterns. And even that word is a bit too grandiose for what they are. This is just the 3 ways that it works. If you see it being done another way, it's probably wrong. Or it's probably an edge case because we always have exceptions to the rule. But these are the 3. Let's start off with the old way. I say it's old because it's the original. There's nothing wrong with doing it this way. It works. It works just fine. It's got some edges. There's some razor blades hiding out there. But it works just fine. And I specifically state that it's pre-iOS 6. In iOS 5, core data drastically changed how they worked. We had a lot, that was the most significant change to core data since its inception in 2004. However, it didn't work at all. They fixed it in 6, and it worked really well from 6 and on, and now it's working great. And in iOS 5, my advice was, don't do it. Just go back to the original way, stay with that, you'll be fine. Don't do the new stuff because it just flat out doesn't work. Very bad things. So I always say pre-iOS 6. And people ask me about iOS 5, I was like, that didn't happen. iOS 5 we skipped. We went from 4 to 6. 5 was a bad dream. So in the old way, the original way, there is one NS persistent store coordinator. And this is what Apple's template gives you. in their very verbose template code is you have this one persistent store coordinator, and it can talk to one or multiple files on the disk, which is awesome. Persistent store coordinator is my favorite part of the code. This thing is, I mean, it's a monster. There's so much stuff that it does, it just blows your mind. But we only had one. We only need one. And it's going to handle, its entire job in life is to make sure that that data gets persisted. And the definition of persisted varies depending on your business needs. So I can't give you exact examples of it, but it goes to disk. It can go to a SQLite database. It used to be able to go to an XML database or an XML file. Don't use XML, by the way. It can go to binary. It can even go to your own file formats now. I mean, with the new incremental store stuff, literally, the world is your oyster. It can go out to a server. Don't do that either. It's unlimited. So all we care about is the NS persistent store coordinator deals with persistence. All our entire application cares about is that it will magically get persisted. It's a black box. We don't have to worry about it. So original way, we only had one. Every NS manage object context talked to that single the NS persistent store coordinator by itself. Every single one of them. So they were all connected to it. So you tended to need access to it. The problem with this is that anytime you made a change in any manage object context, it had to notify the other manage object context. And it notified them in a very public way, to the point where you had to write code to say that this got changed here, I need that change over here. And you had to handle that interaction. You had to handle that cross traffic between the manage object context. And again, this is fine. We can do this. We did it for quite a few years. This way works just fine. If your head thinks this way, stay with it. There's nothing wrong with it. Continue to use it. It's fine. But it's not the greatest. There is a better way now, and it works really well now. Now in this example, and I'll do this in all three examples, is highlight where your truth is. Always, 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 this is where your UI comes from. Your UI connects to the main mock. It only listens to the main mock. So it will only listen to those notifications over there if you are actually listening to notifications. It doesn't care about any of this stuff. All the stuff that comes out of the children, the main mock doesn't care about, should not care about. And if you do listen to that stuff, demons will get you. So why is this the old way? Why don't we still do it this way? Problem number one is it's a tremendous amount of code. When you're done with a fully functional application, core data is a significant chunk of it. I mean, we're talking a lot, and it's everywhere. You have a little bit of code in pretty much every single business class. Every controller has got some core data code in it. It's just kind of spread all around. And that's kind of hard to maintain. And it's hard for the next guy to pick up. And you wrote it, so you've got it in your head. You know where things flow, that when things fly over here, they're over there. That's fine. But the next guy coming in, he's got to go through all that spin up and all that. So it's harder. And then he's got to look at your code and your how you did things and your thinking of it. It's not clearly defined. So there's ramp up time. This is the politest way that I could put this bullet point. Threading rules were a mess. They were completely unclear, beyond unclear. It was almost like they were sending out misinformation just to screw us up. If you actually go back to the old mailing list in 04, 05, 06, when core data was first brand new and trying it out, the authors of core data were giving you different information on different days on threading. Originally, the threading was your job. You lock the persistent store coordinator, you make changes, and then you unlock it. You use one manage object context across multiple threads, and it was opportunistic locking, and good luck. Then they discovered, you know what? People really suck at threading. And they weren't even like pointing at third parties. They're like, no, people in Apple really suck at threading, and we need to change this. So then they came up with the rule of one managed object context per thread, which I'm sure you guys have heard me beat that drum for many years, and that held for a while. But even then, the rules were still unclear, because you could still violate the threading rules. And worse is that it would work most of the time. 99% of the time, it was just fine. And that 1% of the time, it would crash and blow up your entire app, and generally delete data. Another true story. I have no idea what I touched. We had a client coming out of Vegas. They had an app that was a very localized app for only for Vegas. It was to find poker games. You know, what poker games are starting soon, what are the limits, what are the rules, et cetera, et cetera, et cetera. We developed this application for them for a while. It was a good app, no problems with it. And then we sent out one release to the client, and he's like, it crashes on launch. My favorite crash. I'm like, okay, that's weird. He sends us a crash log. Crash log makes no sense whatsoever. It's purely in Apple's code, right? Nothing recognizable in there. And I've seen enough crash logs that I'm starting to recognize the hacks. But even then, it's like, this doesn't make any sense. I don't understand this crash whatsoever. So we start going through every single device we have. And at the time, we were a 15-person company. So you figure, what, 4 devices per person, 60 devices. None of them are crashing. I mean, I'm digging up iPhone 2s at this time, you know, trying to, second generation, so iPhone 3s. Nothing, no crashes. Everything's fine. Call up my buddy who works in binary compatibility at Apple and has hundreds of devices that he can deploy to. Begged a favor from him, sent him a bottle of scotch. He runs it across their entire platform. No crashes. Everything's fine. Call the guy up, and I'm like, I'm confused. I don't understand this. And you know, the one thing that was weird was that he was running an iPhone app on an iPad because he didn't have an iPhone. He didn't like the iPhone for whatever reason. I think he still had a BlackBerry back then. And I'm like, I don't understand. I've run it on all our iPads. I've run it on all of Apple's iPads, and this thing doesn't crash. And he's, you know, showing me a video of it. You know, he's saying, look, boom, blows up. So I was like, okay, fine. What model of iPad do you have? What's the size? Is it a Wi-Fi model? Okay, I'm mailing you a brand new one from Apple today. It will be there tomorrow. Take your iPad, put it in a FedEx envelope, and send it to me. That's how extreme. You know, it's like, here's a brand new. As a matter of fact, I'm upgrading you because I think he had like an iPad 2. The iPad 3 had just come out. So it's like, I'm giving you a new one, better than what you've got now. Send me that friggin' iPad. Sends it to me. I get it the next day. I plug it into my laptop, and it crashes on launch. Fix the bug in 5 seconds. It was a threading issue. It was a lock that was wrong. But he happened to have the one processor on the planet that happened to hit a runtime condition right then and there, consistently. One device, because we had the threading wrong. I looked at it, I'm like, oh crap, that threading's all wrong. That's freaking, how do we get there? And you know, literally seconds later, the thing's fixed, we're done, everybody's happy. Threading is that hard, and you will get that kind of crap. I mean, hell, we still keep that iPad around because that thing will find threading bugs like you wouldn't believe. And they exist because, you know, all processors are not exactly the same. They have a quality threshold. This one was either at the very high end or the very low end. I don't know which. I even took it to Ben at Cordata. I was like, here, watch this. Boom. Isn't that cool? Boom. And he's like, how's that doing that? And I showed him the code. He's like, that's wrong, but that should still work. I'm like, I know, but look, boom, boom. You know, it was really, really cool. And it was in Apple. By the way, it was in Apple's code. The crash. Not sure what's doing that. Okay, I should stop moving. I think somebody else has a mic and they're just scratching it. Actually, that would be funny. That'd be a good way to heckle somebody. Hey, Dave. Yes, I will.
Could you please take out of the pocket? Maybe this one? Yep. Try that.
Okay, even more fun. I got to figure out which hand it goes where. So we have that. We always had that problem with threading, and we always have to worry about that. The threading rules back then were horrendous. And even when you know you got them right, you still got them wrong. That it was bad enough that Apple finally said, or Cordata team finally sat down and said, okay, we're going to change this. We're going to rewrite the threading rules. And they basically rewrote the front end of Cordata to accommodate this. Developers are stupid when it comes to threads. And don't take that as an offense. We're talking, 5 nines here. There's like 5 guys on the planet that get it right every time. On top of this, we've got surprise thread blocking. This was very, very common back in the day. Paid for my house. Just randomly, you have child mocks, and they're working and they're playing, and they go to they do a save out to disk, and your UI stops during the save randomly. You don't know why. I know why. That's how I make my living. But it was hard to get around. It was really hard to work around, and you had to do a lot of work to get it to stop doing that. I've run across a case where we had an app coming in, JSON coming down, and we were parsing 3 megabytes of JSON. This is just text, but 3 megabytes of it. And we got the parsing down to sub 3 seconds. And we were extremely proud of this. We're like, oh, we are awesome. And it took 35 seconds to save. Never did solve that. That fortunately was iOS 4, and then they came out with iOS 5 and said, yeah, we fixed that. Just update. So surprise thread locking, that was another problem with the original way that we did things. And the very chatty notifications. You had to write a lot of notification code to be able to maintain the stuff going back and forth, back and forth. It was a real big pain in the butt. And you didn't want to touch your core data once you got it working, because you knew that as soon as you added something to it, you were just impacted performance somewhere, and you have no idea where, which means a whole new round of QA testing, a whole new round of running it through instruments to make sure that that one line of code you just added the day before release didn't impact production. Made core data have a really bad stigma about it. It's very dangerous, very hard, high risk, low reward, and a lot of people ran from it back in the day. They went over to harder things. The second way, the hard way. Yes, it is the hard way. This is very hard. Hopefully at the end of the slide you'll go, oh my God, I'm never going to do that. But the geeky side of you going, okay, that's cool. When you're using SQLite, SQLite is an amazing application. I had the good fortune of actually hearing a talk by the author of SQLite many years ago, and it blew my mind where this thing gets used. NASA, terabytes, those two are used in the same sentence. Things like that, and it's an incredible application, database, whatever you want to think of it as. And we have this on our phones. Soon we'll have it on our watches. It's incredibly powerful. There's really no end to what it can do. It can handle multiple users. That's one of the core features of a database. It can handle multiple processes talking to it at the same time, and it will solve the problems internally, just like any other database, whether you're using Oracle, Postgres, or any of the others. It can do that. We can do that on any platform. So if it can use multiple processes, we can have more than one persistent store coordinator. No light bulbs. Bummer. We spent so much time with Apple's templates thinking one PSC, one PSC, one PSC, and it was actually Ben that kind of slapped me upside the head going, you can have more than one, idiot. There's nothing stopping you. And I thought long and hard, I was like, oh, that's really, really cool. I could have more than one persistent store coordinator. So that means I could be writing to the database from multiple endpoints at the same time, which means I can have more than one manage object context writing at the same time or reading at the same time. This is cool. This would solve my 20-second write problem. Nope. So it does work. It works really, really well. Really good use cases for this would be something like where you're importing data now that will be used later in the application. That's the best use case for it, is you've got cycles and you don't want to impact the user whatsoever. And it's a massive import, things like that. This is the hard way, again, is when you run into big problems and you're looking for hard solutions. One persistent store coordinator will not block another one. This means you can actually be writing to the disk from multiple persistent stores at the same time. You can write from multiple mocks at the same time. You can do multiple imports at the same time, which is really nice now that we've got these, quad-core, 8-core iPads nowadays. You can spin up multiple cores, and you can warm up your iPad. Some people think when I do this, they're like, whoa. When a persistent store is writing to the disk, it's locking. So how are you possibly writing to the disk simultaneously? Because one of them is going to be locking the table while the other one's not. There's locking going on inside the database. There's still blocking somewhere at some point in time in the universe. They have to be blocking. So I do put in this caveat that yes, there is a sliver of blocking going on all the way down at the set database level. But the reality of it is that when you do a write in core data, 90+% of the time of that write is stuck up at the object level. Is the persistent store coordinator taking your objects and turning them into SQL calls. That takes up a tremendous amount of the processing time of your writes. Even when the write's really small, it's still 90+%. The database is incredibly fast. True story is that it's faster to write into SQLite than it is to write to a file with fopen. Think about that. That's about as low level as we're going to get, and the database is still faster than that. So while yes, there is still some blocking going on, it is a less than a nanosecond when compared to a very significant amount of time inside the persistent store. So even though you've got 3-4 persistent stores writing to the disk at the same time, they're all doing that 90% at the same time, and then standing in line to knock out the 10 or less than 10%. So you may get one, but it will not be human perceivable at all. Only if you're dealing with, like, landing things on the moon or something do you actually need to worry about that level of locking. So this is about as close to true asynchronous processing as we can get inside of core data. But, so in this case, we still one truth. The UI goes to one mock and one mock only. So this is hard. Okay, this is really, really hard to do. This is easily the most advanced core data you're going to get. When you're to this level, you better have a damn good excuse for doing it. Or you're just goofing off, because that's cool. But for production code, there better be, like CEO sign off for doing this kind of stuff, because this is hard. There's no safety nets. There's no conveniences. There's no, they don't do anything for you. You are literally not running with scissors. You are running with a sword, and you're holding it, like this as you're running. I can't stress it enough. This is the hardest way to do it. So why? First, the mocks don't talk to each other. Okay, fine. We dealt with that with the old way. We can deal with that. The persistent stores don't talk to each other. SQLite doesn't tell the persistent store that somebody else has been writing to it. It's completely black. So when persistent store A writes to it, persistent store B has no clue whatsoever, and he can easily overwrite it. Because if they both write to the same row, the same table, one will step on the other, guaranteed, and they'll have no knowledge of it. They'll happily do it. And you're screwed, because you just lost data. Notifications don't work. Not the way we're used to seeing them. If we just say, oh, well, mock A is going to broadcast a notification, mock B will consume it. Yes, if you do about 8 or 9 steps in the middle of that, you can make it do that. But it won't do. It's not just that easy. You just don't throw it over there and consume it and be done with it like we did in the old way. You actually need to say, okay, you need to step in the middle. You need to take that notification. You need to modify the data coming out of the notification, then stick it in the next mock. Doable, but that's a lot of code. More code, more bugs. If we thought threading was hard before, this gets even harder. So again, we're bad at threading to begin with. Now we're just adding another level of complexity because we weren't sure we screwed it up the first time. The next guy will hunt you down and kill you. You will have to change your name and move to another country. And the funnest part is, this is how iCloud works. I just solved that mystery for you. If you don't understand that one, your friend will explain it to you. They probably have scars. iCloud's getting better. I use iCloud. I don't use iCloud with core data still. I find it works better in a more of a document mode, in a plist mode. The iCloud one with core data, it's not so much that it doesn't work anymore. I mean, we've had 3 versions, which should be good now. It's too limiting. There's a lot of limitations to be able to use it with core data, and invariably you're going to step on one of those limitations. That's my ruling right now. It does work though, finally. So that gets us to the best way. How are we doing on time? Ooh, this should be fun. Best, fun word. Means something different to everybody. A lot of people think best is fastest. Nope. A lot of people think that best is the easiest. Maybe. It's definitely not the fastest. Okay, if you are looking for the maximum amount of performance to write to disk, step away from core data. It's not going to be it. It's not what it's designed for. It's quick. It's plenty quick. Surprisingly quick in some areas. I've had plenty of times where I wrote code, go, okay, this is going to suck, and then like, oh no, that was fine. No worries there. But it is not meant to be the performance beast. If you're looking for the maximum possible performance, you're talking to SQLite yourself. You're not writing to disk yourself because that's slower. You're talking to SQLite yourself. And FMDB would probably be the best one I would say there, just to give a concrete example. Best in my mind, and I say this both as a developer and as a business owner and as a consumer of code, it's the most maintainable, which generally is the easiest. So don't be clever. This is kind of invoking Kernighan's law. If you're not familiar with that one, basically saying, debugging sucks. It's really, really hard. And if you write something that you barely understand, you will not be able to debug it. Therefore, it is to your benefit to write code that is stupid simple. That way you can debug it, and the next guy can debug it. You want to keep your code very, very simple, very easy to consume. Maintainability. It's paramount. I can't stress. I would rather have a slower solution than a fast solution that I don't understand. Or worse, I understand it today, but I won't understand it tomorrow. Because then you're just pissing off future you, and then of all the people to piss off, yourself is the worst one. So, what is the best way? Well, this is one I've been preaching for a while. This is one Apple's been preaching. We start off with a singular persistent store coordinator, and then we do something a little bit different, and this is iOS 6 Plus. So if you're still using iOS 4 or 5, sorry, upgrade. We have a private manage object context. Now, for those who aren't familiar with it, private manage object context is one that runs on its own thread. Now, threading's dangerous. But we can't touch that thread. And if we do, bad things will happen. So don't try grabbing it. It does its own, and it does this through blocks. So you just hand it perform blocks, and you tell it to go off and do this. It will hop over to the correct thread, and it will do the right thing. But we're not going to be actually using this thing very much. The only thing we ever tell this guy to do is save. That's his entire job in the universe, is just to save. On top of that, we create a main mock. And in this case, we're specifically telling core data as we initialize it that this is a main queue context. And the importance of that is not so much that core data knows it, is so that core data knows when to slap your wrist. Because if you accidentally grab it off of the wrong thread, it will let you know when you turn debugging on. Now, when they first came out with that iOS 5, they had that turned on by default, that if you grabbed a context by the wrong thread, it would crash your app. Made so much money off that. So many apps do that wrong. I mean, apps today still, you turn on the debug and you're guaranteed you're gonna find at least one call on the wrong thread. It's threading's that freaking hard. So they quickly, it's like, I think it was release 501. They immediately turned that back off because it was crashing like 80 or 90% of the apps. So your main mock, it is connected not to the persistent store, it's connected to the private managed object context. This is one of the new calls that came out in iOS 5 that was usable in 6 of, instead of saying set persistent store coordinator, you say set parent, and then you hand it the private mock. And then below this, you have your children that are doing your imports or your exports or anything else like that. Notice that they all connect to another mock. None of them talk to the persistent store. The data flows through that private mock, and the only guy that saves is the private mock. That's his entire job in life, is just to save. The others you still call save, but all they're doing is moving the data up one level. Our main mock is still our truth. This is the guy that we should be using. Our UI talks to him, nobody else. Now, the nice thing about this is we don't have to deal with notifications. We don't have to write any code to tell the main mock that the child mock has changed something. it will do it automatically because the child knows its parent and it will tell its parent. And then it does, instead of us having to write code and consume objects, it's just doing a little bit of pointer math underneath, and it's very, very quick. Far quicker than we generally are. And then the main mock will handle notifications, and your NSFetch results controllers will work, and your array controllers will work, and everything just magic. You don't have to deal with all of it. All you have to do is you create your child, add some data, hit save, walk away. You're done. It's a lot cleaner. And that's kind of what they were going for. Plus, with the new threading model, they were really trying to make sure that you don't do things on the wrong thread. And they kind of make it not impossible, because developers are clever, but they make it really, really hard to screw up the threading. NS Managed Document does this. This is how it works internally. That is not a recommendation to use the NS Managed Document as your single mock or core data stack in your application. Please stop doing that. One guy wrote up on a blog post about how great it was and you didn't have to stand up core data. It takes control away from you. You can do it, but then you don't really have control over when saves happen, and then saves surprise you, and it creates a bad user experience. Much better just to write those 6 lines of code by yourself and stand up the stack yourself. It's easier. But that's how it works. That's how Apple internally is doing their own stuff, is making sure that private mock is separate. One thing on that, the reason for that private mock is that it makes your saves to disk asynchronous. So when you make a change to something, whether it be the user change or whether it be a data change from you, when you write to disk, you're not blocking the UI. So if you have a 20-second save, you're not blocking the UI. So what's the issues with this? They all have issues. It is the slowest approach. And when I say slowest, I'm talking fractions here. I'm talking nanoseconds. I'm talking you need to do 1,000 processes before you see the difference. It's very, very, very small. But it is slower. It is scientifically slower. If we kick up an app that does 1 million writes and we do it in one way, we do it in the other way, we will see a small deviation. And we're talking even then 5%, 6%, somewhere around there, way below the human threshold, which is the most important thing, especially when we're dealing with mobile. New developers to core data kind of freak out about this. You're compartmentalized. Everything's very, very compartmentalized. If you're doing a data import and you're using an NS operation to grab the data and parse the data and stick it into core data, it's completely siloed by itself, and you don't see any interaction between it and the main context. And then you don't see any action between the main context and the private context. So a new developer to core data comes in and goes, how's this work? There's way too much magic. We got to get rid of this. But once you start to grasp it, you understand how that flow works, and things work out better. It can be more code. Because they're getting rid of the thread confinement queue, we have to do everything either in a private or a main queue, and it can get kind of messy. It's kind of easy to kind of go down that path wrong. And code puke is easy. I've actually got a story for that, but we don't have time for that story. It was hilarious. Catch me later. I'll be happy to share it. So, guidelines. Single source of truth. Have I beat that drum enough today? I hope so. Single source of truth. You only use one mock for your UI. Always, always, always. Do not reuse child mocks. Okay, they're throwaway. If you have a mock that's underneath the main, you use it for one thing and you throw it away. You don't use it again. Do not hang on to it for the life of the app. It can work. It will work 90% of the time. The other 10%, you'll scratch your head wondering where the hell that data went. So main reason for that is because data only flows up, does not flow down. So if you have 2 child mocks, one makes a change, the other one has no idea that it happened. And then you get problems. You can work around this, but that's bad. So better off just to use them once, throw them away, they're disposable. Okay, so it goes down, doesn't go up. Or it goes up, doesn't go down. Great, screwed that up. NSFetch results controller. This is a beautiful piece of code that will ruin your world. It will quietly, in the background, block the main thread because you made a change to the data. And then you will blame core data for it. So this guy is great, but as soon as you have an odd blip in your UI and your UI is not scrolling smoothly, he is the guy. This is the guy that did it. It's not core data's fault. And therefore, instruments. Anytime you have a UI problem, Even if you are convinced that your core data code is perfect, run it through instruments and look at core data first. And probably it's your NS fetch results controller, because the guy who wrote your table view decided to do vector drawing while receiving data, and he's blocking the UI thread. Or worse, calculating pi. I have seen this so many times that I literally, when people call me on the phone, they're like, yep, we got this problem. Yep, we were importing data. Yep, we're using the fetch results controller. I'm like, yep, that's it. No, yeah, it is. Trust me. And then they show me the code. And I'm like, yep, right there. It's like, oh, he is calculating pi. Holy shit. And look, you're blocking the child mock. You're blocking the main mock. Everything. I mean, the entire application across multiple threads has been frozen because he wanted to draw that gradient. So those are my tips. That's my advice for data models and designs inside of core data. Those, in my opinion, are the 3 right ways, and everybody else is wrong. I'll be around for the rest of the day.
We have a time for 2 or 3 questions.
Awesome.
The first one does not count. It's mine. So you just begin your talk about telling me that you have been selected of one of 500 developers who originally was allowed to write code for Apple.
Yes. Yes, so for the iPhone
could you
originally.
Please tell us more about that?
Sure. First, Apple came out with the iPhone, and we said SDK, and they said no. And then they're like, just kidding, here's the SDK, but we're going to only release it to a few people because it's going to change. So at the time, I don't know the exact numbers, but several thousand people then immediately submitted an application for it. And I was fortunate enough to be one of those. And I know it was like, I think it was 512. I want to say that number because it's kind of a cool number. But it was around 500 people were selected as the first release for the SDK. And I was fortunate enough to be in that list.
Okay. The first question?
It's working?
Just yell really loud. Works for me.
So I just want to know, like, probably you heard about Realm. I want to know about like your 2 cents about Realm, the database and the persistent with Realm. Realm.io. If it's not so.
.io. No, I'm not familiar with it yet.
Okay.
I am not, unfortunately.
Okay, so.
So you mentioned that the data flows up from the child to the parent. Any rules on passing it down in case, let's say, a private mock, updates the data in the background, or let's say main single source of truth changes the data while the child is doing some work?
Stop the child, destroy it, build a new one. You can, and I'm going to give this information to you, and this is like giving a gun to a baby. You can take the notifications. I'm sorry, I hope that translated correctly. You can take the notifications from the main and have the child consume it, and then the child can get updated from it. But it's a risky proposition because if the main's not done saving yet and the child goes to ask for it, you can get into a circular lock situation and your whole app just stops and you have to reboot. But it's physically possible. You're much better off just halting whatever the child is doing, destroying it, and start over again. That's the better, cleaner way to do it. I like to think of child mocks as snapshots. That when you created that child and it started processing, it took a snapshot of the database, and that's what it's working on, and that's what it's pushing up, which is great if you're pushing to a server.
So you were talking about consuming your own child, destroying things, and so on. Okay, that's a funny story.
Translations.
Yeah.
Terrible.
Another question?
What do you think about the magical record? And
oh, someone had to throw that out there. What do I think about magical record? I think that Saul Mora has put an awful lot of time in on it. I think he has tried to make core data look like active sync, or active record, I think it's called. I'm not a fan of it. Just put that flat out there. For several reasons. One, I think it takes you too far away from the metal, if I can use that word to describe core data. It abstracts things away from you, and therefore you don't learn. And I generally don't like third-party libraries if I can avoid them. So based on those 2 factors, it's a no-no for me. Other things, I've heard other things, good and bad. It's fitting a square peg into a round hole kind of thing, because it's not active sync, or active record. But generally, just it takes you too far away, and it abstracts things away, and then things become magic, and we have enough magic with Apple.
Yeah. And one last question: the most important takeaway from your talk.
Most important takeaway: single source of truth. There's only one. There can be only one. If you do it any other way, you're wrong, and someone is going to die.
Yeah, Marcus, it was very nice to talk to you.
Great. Thank you very much.